Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. In the last two videos, we have seen the definition of statement, truth value, open sentence, truth table and symbolical representation of logical connectives. In the first video, we have seen that the statements are denoted by what? Small letter. If we are denoting the statement by small letter, then that letters are called as statement letter. Are called as what? Statement letter. If we are denoting the statement by small letter, then that small letter are called as statement letter. And the proper combination of statement letters and logical connectives is called as statement pattern. So take an example. So let us suppose that P is one statement and Q is another statement. If we are connecting these two statements by any logical connective, then such type of representation or such type of proper combination of the statement letter, P and Q are nothing but what? Statement letter, and the connectives. Here connective is what? Implication. Implication is used for which logical connective? If then. Such type of representation is called as statement pattern. Take another example, say negation P or Q. So this is also what? One statement pattern. So another example, say P if and only if negation Q. So here P and Q are nothing but what? Statement letter, and proper combination of statement letter and logical connective is called as statement pattern. So hope the idea about statement pattern is clear to you. So now let us see when we can say that two statements are logically equivalent, means logically equivalent. If the truth value of two statements are exactly same, means are identical, at that time we can say that two statements are logically equivalent. So take an example. First let us try to find out the truth value of P implies Q, and later on we will try to find out truth value of negation P or Q. So okay, so in this case P and Q are two statements under consideration. We know that if two statements are under consideration, at that time how many possibilities of truth values are there? Four possibilities. Which are these four possibilities? True, 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 false, false, true, false, false. If you will observe both the statement here, to find out truth value of P implies Q, we will require truth value of P and Q, which are already known to us. But to find out truth value of negation P or Q, we will require truth value of what? Negation P. Q is already known to us. So let us try to find out negation of P. So truth value of P are known to us. Find out its their negation. What is negation of true? Negation of true is false. Negation of true is false. Negation of false is true. Negation of false is true. Okay, so whenever we are showing that two statements are logically equivalent, at that time denote the column by number. Let us denote first column by say number 1, second column by 2, third column by 3. In the same way fourth and fifth column by number 4 and 5. So now first we are finding truth value of P implies Q. Already truth value of P and Q are known to us. We are finding their implication. So we have seen that implication is false only if first statement is true and second statement is false. This possibility appears here at second number. So for the first possibility, here we will get true. Here T of appears, that's why we can say that implication is false, and here T of does not appears, that's why we can say that implication is true. So already we have seen that implication is false only if first statement is true and second statement is what? False. And here first statement is true and second statement is false, that's why here we can say that implication is false. Now we are connecting two statements. Which two statement? Negation P and Q. By which logical connective? Or. And in case of or, what we have seen, if at least one statement is true, truth value of or will be true. So which is the first statement? Negation P. Truth value of negation P are known to us. Then which is the second statement? Q. So we are connecting these two statements by what? Or. So in case of or, at least one statement is true, result will be true. Here true appears, that's why we can say that result is true. Here both the statements are false, that's why we can say that result is false. Here at least one T appears, एक भी T आ गया तो result क्या होगा? True. So here also at least one T appears, so result will be true. So truth value of first statement is also known and truth value of second statement is also known to us. Now check whether truth value of both the statements are exactly same or not. So what are the truth value of P implies Q? TFTT, and here also truth value are TFTT, means truth value of both the statements are exactly same. So that's why from column 4 and 5, what is our conclusion? That P implies Q is equivalent to negation P or Q, and if two statements are logically equivalent, then it is denoted by this symbol. So means we can say that these two statements are logically equivalent. So hope the idea about how to show that two statements are logically equivalent is clear to you. Just simply find out their truth value and check whether the truth value of both the statements are equivalent, means identical or not, exactly same or not. If the truth values are identical, we can say that two statements are logically equivalent. Now let us see when the statement pattern is called as what? Tautology. A statement pattern is called as tautology if it is always true. If it is always true, at that time we can say that statement is what? Tautology. Let us consider one example. Let us consider one statement, say P. If only one statement is under consideration, then only two possibilities are there. Either this statement is true or this statement is what? False. So let us try to find out negation of P. So or truth value of P are known to us. We are finding their negation. What is negation of true? False. And negation of false is what? True. Now we are connecting these two statements by OR. In case of OR, what we have seen, if at least one statement is true, truth value of OR will be true. So truth value of P and truth value of this negation P is known to us. We are connecting them by what? OR. If at least one statement is true, truth value of P or negation P will be true. So here observe the first case S. One statement is true. So if at least one statement is true, truth value of OR will be true. So here also at least one statement is true. So we can say that truth value of P or negation P will be true. So means what we are observing here, this statement is always true. And if the statement is always true, at that time it is called as tautology. In the same way, if the statement is always false, at that time it is called as contradiction. So now let us connect these two statements by AND, P and negation P. In case of AND, which condition we are remembering? We are, if at least one statement is false, if at least one statement is false, truth value of AND will be false. So observe in the first case, yes, one statement is false, so truth value of this AND will be false. Here also at least one statement is false, so here we will get result false. In case of AND, simply remember that if at least one statement is false, truth value of AND will be false. Here we can observe that the truth value of this statement is what? FF, means this statement is always false, and since the statement is always false, so it is called as what? Contradiction. And contingency. Contingency means this statement which is neither tautology and nor contradiction. Tautology means what? Always true. Contradiction means what? Always false. So let us check the truth value of P implies Q. Check whether it is tautology. No, here F appears. So means it is not always true. So that's why we cannot say that it is tautology. Check whether it is contradiction or not. When we can say that it is contradiction, if it is always false, means in all possibilities, if it is false, means it is always false. But here it is not always false, so we can say that it is neither tautology nor contradiction. And such type of statement pattern which are neither tautology nor contradiction are called as what? Contingency. Means to check whether the statement pattern are tautology, contradiction or logically equivalent, we have to construct their truth table. To check whether statement pattern are logically equivalent or not, another method is also there, but one method is what? By constructing the truth table, we are able to check whether the given statement pattern are logically equivalent or not, or whether the statement pattern is tautology, contradiction or contingency. So using this method, now we are solving the example from our next exercise. Hello friends, most welcome to my YouTube channel Maths by Samit Deshmukh. So today we are solving example from exercise 1.2. All the example from this exercise we have to solve using truth table. So first of all, let us revise all the result related with what? Truth table. So already we have seen that in mathematical logic, how many logical connectives are there? 5. In case of not, what we have seen? Negation of true is false. Not means what? Negation. So negation of true is false and negation of false is what? True. So simply you have to remember these results, that negation of true is false and negation of false is true. Then second logical connective is what? And. In case of and, you have to simply remember that if at least one statement is false, truth value of and will be false. Then third logical connective is what? Or. Or is also called as disjunction. And in case of or, what we have seen, if at least one statement is true, then truth value of or will be true. Next logical connective is what? If then. If then is denoted by what? Implication, which is called as conditional statement. And in case of if then, means in case of implication, simply you have to remember that if T of appears, at that time only implication is false. T up means what? First statement is true and second statement is false. At that time implication is false. And last logical connective is if and only if. In case of if and only if, means in case of double implication, if and only if is denoted by what? Double implication, which is called as biconditional statement. In case of double implication, simply remember that if truth values are identical, identical means what? Truth value of both the statement are true or both the statements are false. At that time only double implication is what? True. Otherwise it is false. Otherwise means what? If truth value varies, one is true, another is false, at that time double implication is false. If we are remembering these techniques, easily we are able to construct truth table, and at least one example is always there in the examination which we have to solve using truth table. So using this result, now we are starting question number first. In question number first, we have to construct the truth table of each of the following statement. So observe the first statement. First statement is what? P implies Q and Q whole bracket implies 2P. If you'll observe this statement very carefully, how many letters? Letter means what? Statement appears, because statement we are denoting by what? Small letters. So here two statements are there. Which two statements? P and Q. So if two statements are under consideration, at that time we know that how many possibilities of truth values are there? 4. Which are these 4 possibilities? True, 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 false, false, true, and false, false. So write down these possibility in this form, so that true, true, false, false, true, false, true, false. Otherwise remember it in this way: true, 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 false, false, true, false, false. Now let us try to construct the truth table of this statement. If first we are finding truth value of this bracket, so let us try to find out first truth value of P implies Q. So P implies Q. In case of implication, simply remember that if first statement is true and second statement is false, at that time only implication is false. First statement is true and second statement is false appears here. So this possibility appears here. So here only the statement is false, otherwise it is true, isn't it? And if in case of implication, if first statement is false, at that time not necessary to observe the truth value of second statement. Directly we can say that the truth value of implication will be true. If first statement is false, not necessary to check the truth value of second statement. Getting it? Because we know that implication is false only if first statement is true and second is false. अगर first statement false है तो second की truth value देखने की जरूरत नहीं है. Just directly we are able to say that implication is true here. Once the truth value of P implies Q is known to us, then find out the truth value of P implies Q and Q. So P implies Q and Q. So here truth value of P implies Q is also known to us and truth value of Q is also known to us. So now we are connecting these two statements by which logical connective? And. These two statements we are connecting by and. And in case of and, what we have seen, if at least one statement is false, truth value of and will be false. Here F does not appear, that's why we can say that it is true. Here F appears, so that's why we can say that it is false. Here F does not appear, so we can say that here we will get true. And here F appears, at least one statement is false, truth value of and will be false. So in this case, this first row is only for denoting the columns. So this, let us denote first column by 1, second column by 2, third column by 3, and fourth column by what? 4th. And here last column, let us denote it by 5. Now here this much part means it lies in which column? 4th column, means it will become 4. So now here, instead of writing this whole statement, just write down what? 4. 4 implies, 4 means what? This statement, P implies Q and Q, P implies Q and Q, which truth value of this statement lies in which column? 4th column. So instead of writing this whole statement, just simply write down 4. And 4 implies to what? Implies to P. So truth value of 4 is also known to us. 4 means this whole statement, and truth value of P is also known to us. And we are connecting these two statements by what? Implication. In case of implication, if first statement is true and second statement is false, at that time only implication is false. So let us see, this is first statement and this is second statement. Check whether TF appears. No, TF does not appear, so it is true. Check whether TF appears. No, FT is there, so it is also true. Here TF appears. Observe that first statement is true and second statement is false. So that's why we can say that here implication is false. In the last case, first statement is false. First statement is false, so not necessary to check the truth value of what? Second statement. So in this way, we are constructing truth table of the given compound statement. Now let us try to solve the second example. In the second example, observe the statement. How many letters? Letters means what? Statement. How many statements are under consideration? P, Q. So only 2 statements are under consideration. So that's why we will get 4 possibilities of truth value: true, 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 false, false, true, and false, false. So let us denote this column by 1 and second column by 2. Okay, so now if you'll observe this statement here, we will require the truth value of what? Negation Q. So first we are finding negation Q. So truth value of Q are known to us, so easily we are able to find out its negation. We know that negation of true is false, negation of false is true, again negation of true is false, negation of false is true. Now truth value of P is also known, truth value of negation Q is also known. We have to connect these two statements by what? And. So what we'll get here? P and negation Q. Let us denote it by column number 4. So here we are connecting these two statements by which logical connective? And. In case of and, if at least one statement is false, result will be false. Here F appears, so we can say that this statement is false. Again, if you'll observe here, truth value, both are true, so result will be true. Here at least one statement is false and will be false. So in this way we have got truth value of P and negation Q. Now we are finding truth value of P implies Q. P implies Q. Let us denote it by column number 5. So truth value of P and Q are known to us. We are connecting these two statements by which logical connective? Implication. In case of implication, simply observe that TF appears. At that time only implication is false. So here this possibility appears. First statement is true and second statement is false. So here implication will be false, otherwise implication will be true. Lastly, let us denote this statement and the second statement. First statement means what? Its truth value appears in column number 4. Truth value of this statement appears in column number 5, and we are connecting these two columns by which logical connective? Double implication, means for if and only if 5. Means we are connecting these two statements. This statement 4 means what? P and negation Q, and 5 means what? P implies Q, and we are connecting these two statements by double implication. Let us denote the last column by column number 6. Now connect these two statements by what? Double implication. In case of double implication, simply you have to remember that if truth values are identical, double implication will be true. So here truth values are not identical, one is false, another is true. That's why here we can say that it is false. So here also false. Here also truth values are not identical. Here also truth values are not identical. In this way we have constructed the truth table of the given statement. And here we can observe that this statement is always false. This statement is always false, and the statement which is always false is called as what? Contradiction. Here question is not asked to check whether it is tautology, contradiction or contingency, but you should easily, we can observe that here all the truth values in the last column are false, means this statement is always false. Such statements are called as what? Contradiction. And here we can observe that it is neither tautology nor contradiction. Such statements are called as what? Contingency. Now observe the example number 3rd. In this example number 3rd, observe how many letters, means how many statements are under consideration. P, Q, R. 3 statements are under consideration. Whenever the 3 statements are under consideration, at that time let us see how many possibilities of truth values we are getting. One possibility is that all the statements are true. All the 3 statements are what? True. First statement is P, second statement is Q, and third statement is R. Second possibility may be possible that all the statements are what? False. Otherwise, the next possibility that 2 statements are true and 1 statement is false. If 2 statements are true and 1 statement is false, then may be possible the statement which is false is the third one, or may be possible the statement which is false is second one, or may be possible that it is false statement is first one. Means again here we are getting 3 different possibilities. Or may be possible that 2 statements are false and 1 statement is true. The statement which is true may be last one, or maybe second one, or maybe what? First one. In this way we have got total 8 possibilities of truth values if 3 statements are under consideration. The standard method to write down these 8 possibilities are, just simply remember that here take 4 times true. True, 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 and 4 times false. This is the standard method of writing all these 8 possibilities. So in the first column, after taking 4 times true and 4 times false, in the second column, then write down 2 times true, 2 times false, 2 times true and 2 times false. And in the third column, write down T, F, T, F, T, F, T, F. In this way, we are writing these 8 different possibilities. Denote the first column by number 1, second by number 2, and third by number 3. Now, here to find out truth value of this statement, first we have to find out truth value of P and Q. So, first find out truth value of P and Q, then find out truth value of Q or R. Let us denote these by column number 4 and these by column number 5. In this case, truth value of P and Q are known to us. We are connecting them by what? AND. In case of AND, we have to remember that at least 1 statement is false, truth value of AND will be false. Observe here, false, 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 false. Means in last 6 cases, we are getting false. Here we will get true. True, true, false, 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 and false. Now we are finding truth value of Q or R. So truth value of Q and R are known to us. We are connecting these 2 statements by which logical connective? OR. In case of OR, simply we have to remember that if at least 1 statement is true, truth value of OR will be true. So observe that here true, true, true appears. So means here we will get true, 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 and then false, false. Then what? True, 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 false. True, 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 false. If at least 1 statement is true, truth value of OR will be true. Now we are connecting this statement. This statement lies in which column? 4. And this statement lies in which column? 5. And these 2 statements we are connecting by which logical connective? Double implication. So new column, let us denote it by next number 6. Now we are connecting these 2 statements by which logical connective? Double implication. In case of double implication, simply you have to remember that truth values are identical, double implication will be true. So here truth values are identical, so true. Here also truth values are identical, so true. Here truth values are not identical, so it will be false. Then observe here truth values are identical, so it will be true. Now here truth values are not identical, so it will be false. So here also truth values are not identical, so it will be false. Here also truth values are not identical, so it will be false. And lastly, truth values are identical, so it will be true. In this way, we have constructed the truth table of given statement. Now let us try to solve the next example. Here also, if you'll observe the statement, how many letters, means how many statements are under consideration, P, Q, R. If 3 statements are under consideration, at that time already we have seen that 8 possibilities of truth values are there. Which are these 8 possibilities? True, 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 true. In the first column, first write down 4 times true and 4 times what? False. In the second column, write down 2 times true. True, true, false, false. True, true, false, false. In the third column, true, false, true, false, true, false, true, false. So well, we have considered all the 8 possibilities here. If you'll observe here, first part is what? P, whose truth values are known to us. Now let us try to find out truth value of this second part. To find out truth value of this second part, first we have to find out Q and R. Q and R. Once the truth value of Q and R is known to us, then we are able to find out its negation, means negation of what? Q and R. Denote this column by 4 and this column by 5. Now truth value of Q and R are known to us. We are connecting these two statements by which logical connective? AND. In case of AND, simply we have to remember that if at least one statement is false, AND will be false. Here both are true, so result will be true. Here one statement is false, so result will be false. Here also false, false, and true. False, false, true. Here false, false, false. At least one statement is false. Truth value of AND will be what? False. Now we are finding negation of Q and R. Negation of Q and R. In case of negation, negation of true is false and negation of false will be true. So let us try to find out negation of this statement. So negation of true is false. Negation of false is what? True. Again, negation of false is true. Negation of false is true. Negation of true is false. And negation of all these false are what? True. In this way, we have got the truth values of negation of Q and R. Now observe this statement. P, first part is what? P implies this second part. This second part, truth value of second part lies in which column? 5. So we can say that P implies 5. Let us denote this new column by number 6. Isn't it? So now, in case of implication, what method we have seen? If first statement is true and second is false, at that time only implication is false. Check whether here TF appears. Yes, TF appears, so it will be false. Here TF does not appear, so it will be true. Here TF does not appear, so it will be true. Here also TF does not appear, so it will be true. And later on, first statement is false. If first statement is false, at that time implication is always what? True. Whatever may be the truth value of this second part. So here we will get true, 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 because first statement is false. At that time implication is what? True. Now see the example number 5th. In this case also 2 letters appears. P and Q, means only 2 statements are under consideration. P and Q are 2 statements under consideration. If 2 statements are under consideration, then the truth values, means 4 possibilities of truth values are there. True, 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 false, false, true, and false, false. Let us try to find out negation of P, because we will require negation of P. Even we will require negation of Q also. So first we are finding negation of P and negation of Q. So truth value of P are known to us. So find out its negation. Negation of these true are false and negation of false will be what? True. Now from the truth value of Q, find out negation of Q. So what is negation of true? False. Negation of false is true. Negation of true is false. Negation of false is true. Now first part is known to us. What is the first part? Negation P. Its truth value is known to us. Now let us try to find out truth value of this second part. But to find out truth value of this second part, first we have to find out truth value of P or negation Q. Let us denote this column by number 5. So truth value of P is also known and negation Q is also known, and we are connecting these two statements by OR. In case of OR, simply you have to remember that at least one statement is true. Truth value of OR will be true. Here one statement is true, so truth value of OR will be true. Again, here both are false, so result will be false. Here one is true, so result will be true, because OR is true if at least one statement is true. Now first part lies in which column? 5. This part lies in which column? 5. 5 and Q. Let us denote this column by 6, means this whole statement lies in column number 6. Now observe this phi u and this Q. These two statements we are connecting by AND. In case of AND, at least one statement is false, truth value of AND will be false. So both are true, so result will be true. Here one statement is false, so AND will be false. Here also one statement is false, and here also one statement is false, so AND will be false if at least one statement is what? False. Now connect these two statements, negation P and this statement, truth value of this whole statement lies in which column? 6, and we are connecting these two statements by AND. So let us denote this new column by number 7. So observe the truth value of negation P and the truth value in column number 6. We are connecting them by AND. In case of AND, if at least one statement is false, truth value of AND will be false. So here one statement is false, here also false. So here in first two cases, at least one statement is false, result will be false. And here we can observe that here also false is there, one statement is false, and will be false. Means, and here also false is there, so that's why we are getting truth value of AND will become what? False. In this way we have constructed the truth table of this statement, but here also we can observe that this statement is always false. Such statements are called as what? Contradiction. Now let us try to solve the example number 6. In example number 6 also we can observe that two letters are there, P and Q. Since two letters are there, means two statements are under consideration, so that's why we will get 4 possibilities of truth value: true true, true false, false true, false false, isn't it? Now if you'll observe this statement, in this case we will require the truth value of negation P also and negation Q also. So first we are trying to find out truth value of negation P and negation Q. So denote this column by 3 and 4. So from truth value of P we will get its negation. Negation of true is false, again negation of true is false, and negation of false will be what? True. Find out negation of Q from its truth value: false, true, false, true, because negation of true is false and negation of false is true. Once the truth value of these two statements are known to us, now we are connecting these two statements, means negation P and negation Q, by which logical connective? Implication. Denote this column by column number 5, means this statement appears in column number what? 5. Now in case of implication, what condition we have to remember? If first statement is true and second is false, implication will be false. So observe here, TF does not appear, so implication is true. Here also TF does not appear, so implication is true. Here TF appears, so implication is false. Here TF does not appear, so implication is true. Now we are connecting these two statements. Negation Q implies negation P, means we are connecting these two statements by implication. Okay, and again in case of implication, remember the same condition. If first statement is true and second statement is false, at that time implication is false. Now in this case, which is the first statement? Negation Q, and second statement is what? Negation P. So here this is first statement, this is second statement. Check whether TF appears. No, TF does not appear, so it is true. So here TF appears, this is first statement and this is second. TF appears, so it will be false. Here TF does not appear, so it will be true. Here also TF does not appear, so it will be true. So lastly, denote this statement appears in which column? 6. So we are connecting these two statements 5 and 6 by which logical connective? AND. So truth value of first statement lies in column number 5 and truth value of the second statement lies in column number 6, and these two statements we are connecting by AND. In case of AND, simply remember that at least one statement is true, at least one statement is false, truth value of AND will be false. So here F does not appear, so it will be true. Here F appears, so it will be false. Here also F appears, so it will be false. And lastly, F does not appear, so it will be true. In this way, we have got the truth value of this statement. Here we can observe that this statement is neither tautology nor contradiction. Such statements are called as what? Contingency. Now see the question number 7th. In this question, so one statement is given to us. If you observe this statement, only two letters are there, P and Q. Means here if two letter means two statements are under consideration, then these are 4 possibilities of truth value. Let us construct the truth table of this statement for these 4 possibilities. If we'll observe this statement very carefully, here we will require the value of negation P. So first we are finding truth value of negation P using the truth value of P. So we know that negation of true is false, and this negation of false will be equal to true. Now find out implication of which two statement Q and P. We know that implication is false if first statement is true and second statement is false. This is our first statement and this is second statement. Q is first, P is second statement. So TF appears? No. In the first case TF does not appear, so it is true. Here also TF, this is first statement. TF does not appear, so it is true. Here TF appears, so it is false, and here TF does not appear, so it is true. We know that implication is false only if first statement is true and second statement is false. Now let us connect these two statements. Which two statement? Negation P and Q, by which logical connective? Double implication. Double implication. So truth value of negation P is also known to us and Q is also known to us. And in case of double implication, if truth values are identical, double implication is true. So here truth values are not identical, so it is false. Here truth values are identical, that's why it is true. Here truth values are identical, that's why it is true. Here truth values are not identical, that's why it is false. So now this part appears in which column? 4, and truth value of this second part appears in column number 5, and we have to find out or of these two statements, means 4 or 5. So observe these two statements in column number 4 and in column number 5. The truth values are known to us, just we are connecting these two statements by or. And remember that in case of or, if at least one statement is true, truth value of or will be true. So true, 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 and here also true. At least one statement is true, truth value of or will be true. So here we will get true, 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 true. So here true appears, here true appears, here true appears, and here also true appears. Means if at least one statement is true, truth value of or will be true. Now see the example number 8. In this example number 8, if you will observe the given compound statement, here 3 letters appears, P, Q, R. 3 letters appears means here 3 statements are under consideration. In such cases we will get these 8 possibilities of truth value. How we have got these possibility, that part already we have discussed. Now let us try to find out truth value of this first part. So first we have to find out Q implies R. Q implies R. Truth value of Q and R are written here. We are connecting these two statements by implication. In case of implication, TF appears, at that time only implication is false. So here true, true is there, so statement will be true. TF is there, so false. Here TF is not there, so true. TF is not there, so true. Here also TF does not appear, true. Here TF appears, so it is false. Here TF is not there, so true. Here also TF is not there, so true. Now we are connecting these two statements, means P and Q implies R by implication. By what? Implication. So truth value of P are also known to us and Q implies R is also known to us, means column first and column fourth we are connecting by which logical connective? Implication. Again in case of implication we know that if first is true, second is false, at that time implication is false. Here TF does not appear, so true. Here TF appears, so false. Here TF does not appear, so true. Here also TF does not appear, so true. And in case of implication, if first statement is false, implication is always what? True. Not necessary to check the truth value of second statement. Now to find out truth value of second part, first we will require the value of what? P and Q. So these two statements we are connecting by and in case of and, if at least one statement is false, truth value of and will be false. So P and Q, these two statements we are connecting by and. True, 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 means here we will get T, and here false, 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 false. At least one statement is false, truth value of and will be false. So in remaining cases here at least one statement is false is there, so that's why truth value of P and Q will be false. Now truth value of P and Q is known to us. P and Q, it implies to what? R. Again, in case of implication, if first statement is true and second statement is false, at that time implication is false. So this is our first statement and this is our second statement. So TF does not appear, so it is true. Here TF appears, so it is false. If first statement is false, at that time implication is always what? True, not necessary to check the truth value of second part, because in the first part F appears, so not necessary to check what are the truth value of second statement, because we know that in case of implication, if first statement is false, then whatever may be the truth value of second statement, implication is always true. Lastly, let us connect these two statements. This truth value of this statement appears in column number 5 and truth value of this statement appears in column number 7, and we are connecting these two statements by double implication. By what? Double implication. So let us try to find out truth value of 5 double implies 7. So 5 and 7. Observe the truth value, double implication is there. At that time, if truth values are identical, so double implication is true. So true, so identical, here also identical. So truth values are identical, here also truth values are identical, again identical, again identical. Identical means exactly same. At that time double implication will be true. Here we can observe that for all these 8 possibilities, this statement is true, means we can say that the statement which is always true is what? Tautology. Here also this statement is tautology. Here also we can observe that this statement is also what? Tautology. So example number 9 is nothing but fourth example from the same question first, which already we have solved. So see to refer this example, see the solution of fourth example in the same question first. Now let us try to solve the example number 10th. If you'll observe the statement here very carefully, 3 letters appears, P, Q, R, means 3 statements are under consideration, so we will get these 8 possibilities of truth value. Observe this statement very carefully. Here we will require the truth value of negation of Q. So truth value of Q are known to us, find out their negation. Negation of true is what? False. Again, negation of this false is what? True. Negation of true is what? False. And negation of false is what? True. Okay. So now to find out truth value of this first part means what? P or negation Q. We have to connect this negation Q and P. By which logical connective? Or. In case of or, at least one statement is true, or will be true. So here true, 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 true. In the first 4 cases we are getting true. Again observe here, we are connecting this column first and column fourth by or. So here T does not appear, so here we will get false. Here TT appears, so we will get what? True, because if at least one statement is true, or will be true. Later on, let us try to find out truth value of Q and R and P. So truth value of R is also known to us and P is also known to us. In case of AND, if at least one statement is false, truth value of AND will be false. So observe these two parts, P and R. So here TT appears, so result will be true. Here false appears, so result will be false, because at least one statement is false and will be false. Here both are true, so result will be true. Here one statement is false, so result will be false. Here false, 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 means at least one statement is false. Truth value of AND will be what? False here. Once the truth values of first and second part is known to us, first part appears in which column? 5. Implication, keep it as it is. Second part appears in column number 6. Now 5 implies 6. In case of implication, simply remember that if first statement is true and second is false, implication will be false. So both are true, so result will be true. TF appears, so implication is false. TF does not appear, so true. TF appears, so it is false. So here first statement is false, so not necessary to check what is the truth value of second statement, because implication is always true if first statement is false. Here TF appears, so it is false. Implication is false if TF appears. Here also TF appears, so implication is false. In this way we have completed first 10 example from question number first. In the next video we will solve question number 2 and question number 3.